Hi, this is Dana with GMAT Ninja, and today I'm going to be talking about the graphical interpretation questions that you'll see on the data insight section of the GMAT. So this is just an introduction to, you see these graphs, you see these charts, what do you do with them? How do you approach those kinds of questions? None of these questions that we go over in this video are going to be knock your socks off difficult. We'll start with a couple of easy questions and then move into a couple of medium questions. But really the point is just to get that overall approach down of what to do when those things pop up on the screen. We'll go over line graphs, bar charts, pie charts, and flow charts in this video, which are some of the more common things that you'll see on the data insights section, although you're always going to see those outlier weird graphs, and those will be covered in a different video. So before we dive into particular questions, what is that overall approach? What should you do when you see a graph or a chart on data insights? The problem that we see most frequently with our students is that they rush into the questions before they really understand the information that is presented in the graph or on the chart. So you don't want to do that. So our approach is all about giving yourself a little bit of time to orient yourself to that graphical information before you move on to the question. And what should you do with that time? A couple of things to consider. First is that it's important to read the title and description of the graph so you see what information that gives you. Second, you want to pay attention to the axes and what exactly is on each axis of the graph. And finally, you want to tell yourself the story of what information is presented on that graph. Give yourself a little bit of a narrative of, okay, I see how this information all fits together. So we'll go ahead and give that a shot. What I will do is I'll put a line graph up on the board and I'll give you about 20 seconds to just do this. I won't put the actual questions themselves up. Just want you to orient yourself to that graph and see what information you can get out of it. So I'll go ahead and pop that up right now. Alright, so let's talk about this line graph. Now, if you need more time, you can always go back to that previous screen and pause for as long as you need to, but otherwise let's chat it through. So you can tell that this is a line graph because it's got lines, so nothing too crazy going on there. And here, if you look at the axes, we have some dates along the bottom. That's pretty easy to interpret. We're just showing from kind of the mid-1400s going up to the early 1600s, something that's changing over that period of time. I think that the other axis is difficult to understand until you've read the description. So it says percentage of U. What the heck? What does that mean? I don't really know. So let's go to the description of the graph to figure it out. The description says that the graph indicates the results of early written material from, the graph indicates results of a survey of written material from 3 areas in early modern England. And then if you look at the key, we've got these 3 areas, London, North, and East Anglia, and each of those 3 corresponds to a different line on our chart, so that makes sense. Then we're told the graph shows the percent of the use of you when either you or ye would be appropriate. So I guess there are some cases in which you could either say you or you could say ye, like ye old merry tavern or whatever. And what we're shown in this graph is how often are you choosing to say you. Now, looking at this overall story then, what we see is this shift of very few people using you at the beginning, right? So we're sub 20% of the time using you when you could use ye. And then as the graph goes to the other side, then we see that that percent of you goes way, way, way up, pretty much to 100% by the time you get to the end of the graph. So over time, the story that's being told here is that most people used to say ye, and then things changed, and by the end, most people used you for about 100% of the times that they could use either. So that's the overall story of this graph. Seems pretty straightforward, and so now is the time when you can go ahead and dive into the questions themselves. So I'll go ahead and I'll pop those questions up here. There are 2 questions. I'll give you a couple of minutes to answer those 2 questions, and as always, if you need more time, feel free to pause, and then we will chat them through. All right, let's go ahead and talk through these two questions. So the first question asks, the area of early modern England that was first to favor the use of you over ye was London, the North, or East Anglia? Which one? So here I'm looking at first to favor the use of you over ye. What does that mean? Well, that means that you're more likely to use you when you could use either. In other words, that percentage of you should be above 50% if you're favoring you over ye. So this is a pretty simple question then. All we do is we go up on the y-axis to see, hey, where's that 50% mark where we are starting to favor you? And then just track it along across the line and see, well, who was first? Of these three lines, which one crosses that horizontal line at 50% first? And if you just do that, go up to that 50% mark, which isn't marked, but it's just going to be between the 40 and 60, and just trace it across with your eyes, you'll see that very, very clearly the London line is the first to intersect with that 50% line, which tells us that London was the first area that would favor the use of you over ye. So the answer to question 1 will be A, London. The second question asks, in the surveyed writings from the area of the North between 1520 and 1559, you constituted what percent of the instances in which either you or ye would have been appropriate? So now we know that we're looking at the North, so go to your key, take a look at which line, and we're looking for that orange line. And we are looking specifically between 1520 and 1559, so just look on the bottom axis and get to that point, 1520 to 1559. And we're looking just for a percent where you would use you instead of using ye, and that's exactly what we're shown on our y-axis. So at that point, orange line, 1520 to 1559, what percent are using you? 20%. So that is our final answer for question 2, C, 20%. So that's a line graph. It's just going to show two axes that are related to each other and what happens with your data as you change both of those axes. We will next go ahead and look at a bar chart, and the overall approach remains exactly the same. First, spend time with the chart itself and orient yourself to the information there before you dive into the questions. So again, I'll give you about 20 seconds to go ahead and read the description of this graph, take a look at it, and then we will chat about the graph itself, and then we'll go through some of the questions. All right, let's go ahead and discuss this bar chart. So what it looks like is that we've got some letters on the bottom, BE, DK, etc. And then with each pair of letters comes a pair of bars. So we've got 2 bars that correspond with each of these things along our bottom axis. I think it's easiest again to start with the description here. So it says, in 1979, when the EU elected its first parliament, the Union had 9 member states. So we've got those 9 member states listed on the bottom. And then the graph shows 9 pairs of bars, one for each of those 9 member states, and talks about what happened with that parliament in 1979 and in 2009, with also breaking down the men and the women in each parliament. So this is when I might just choose one data point to go in and tell myself that story of what's going on. Let's just start with Belgium, just because it's the first one that is listed. What this shows us is that the number of people in the parliament was a bit higher in 1979 than in 2009, right? So it looks like that blue and white bar goes to about 24 total people, and then the black and gray goes to about 22 total people. But that the number of women was much lower in 1979 than in 2009. That little blue square at the top of that bar is pretty small, and then the gray square is just a little bit bigger. So, overall kind of gives us a sense of how many people were in the parliament and how many of them were men versus women. And then, of course, you can look across the other nations and see what was happening with them. Same sort of data being presented, but a different story for each one. So now that you understand the graph itself, let's go ahead and answer some questions. I will put them on the screen. There are 2 questions this time. and take your time, answer those, and then we will discuss after a couple of minutes. All right, let's go ahead and talk through these questions. So if you need more time, feel free to go back to the previous screen and pause for as long as you need. But let's dive in. So the first question asks, if a member were chosen at random from each state members in the 1979 Parliament, the state with the most likely to have had a woman chosen is blank. So that's asking about proportionality, right? So it's asking, if I select from this whole population, where am I most likely to pull a woman out of that pool? And we're also specifically talking about 1979, which tells us that we're dealing with the white and blue bars, and we don't really care about the black and gray bars for this particular question. So you could go through each and every one of these options and see what your total number of people is in the parliament and then how many women you had. Put those as a fraction, right? So you've got your total number of women over your total population, and then compare all of those fractions to one another. To me, that's just kind of a lot. I don't really want to do that for my 4 options. So let's see if we can make any quick comparisons just visually using the information in the chart. So the easiest ones to compare for me are those tall ones because they're all, if you see, roughly at that same level, right? So we've got the same total population, roughly, in each of those 4 countries. And then out of those 4 countries, it looks like in our options we have France and we have the UK. So between France and the UK, which one proportionally has a higher number of women? Well, it looks like that blue chunk in the France bar is much bigger than the blue chunk in the UK bar, and again, the total population is the same, so we can say, hey, yeah, if I was to choose just between those 2, I'm more likely to end up with a woman if I choose in France versus in UK. So that means that I can just go ahead and get rid of UK without really doing much math at all. Same thing with my shorter bars. Now I'm looking to see, hey, can I make any eliminations just visually instead of putting exact numbers in? And out of my shorter bars, I'm dealing with DK and with NL. So let's take a look. If I look at DK and then I compare to NL, what happens there is the total populations are different, right? The NL population is higher than the DK population. But the bar for women is actually higher in DK than it is in NL. So what that tells me is that I'm much more likely if I choose from the DK pool to pull a woman than if I choose from the NL pool. So again, don't have to do any math here. I can just visually see that I'm going to have a higher proportion in DK than I would in NL. So from there, you could do a visual comparison between our remaining options, DK and FR, but to be honest, I don't really feel comfortable with that. You know, I'm like, ooh, if I scale that up, what would happen with my blue bar? To me, it feels just a little too wishy-washy. So this is when I would go in and do the actual numbers just to see if that really clarifies matters. So what I'm doing is I'm just going to see like, hey, what's my total population in the parliament, and then how many of those are women? Starting with DK, our total population looks to be around 16. And then our number of women, and again, it doesn't have to be totally accurate here because we're not given, you know, one by one on the scale, but to me it looks like 6. So I'm guessing that we've got about 6 out of 16 women out of our total population. Same deal for France. What's our total population? To me it looks like about 81. And then for the number of women within that population, you know, we span across 3 of our bars, right? So you know and each bar is 5. So you know we've got at least 15. To me, it looks like we go a little bit below that and a little bit above that. So I'm going to go ahead and say that we've got around 18 out of 81 women out of our total population for France. Now, looking at these two and comparing them, this is a bit over 1/3. And then this is a bit under 1/4. So very clearly, DK is going to be higher than FR, and that is our winner for question 1. Moving on to question 2. If the member states were arranged in order from the least number of members to the greatest number of members in the 1979 Parliament, blank would be in the middle. So we're just talking about the total number, so just the height of the bar. We don't really care about that split between men and women. And again, we are talking about 1979, so we are dealing with the white and blue bar, not with the black and gray bar. Now, you could rank order all 9 of these, but that, again, is kind of inefficient. Don't really want to do that. So instead, I'm going to think carefully about what the middle one means. We've got a population of 9 total states. So which one is going to be smack dab in the middle? It's going to be the 5th one, right? So you'll have 4 smaller ones, and then you'll hit the 5th one, and then you'll have 4 larger ones. So number 5 is the one that's right in the middle. So I don't have to count all 9. All I have to do is determine, hey, which one has 4 below it or 4 above it. Here, I think it's easiest to see the 4 that are the highest, right? So we can just like immediately get rid of those tall 4, right? So we've got DE, we've got FR, we've got IT, and we've got UK. Those are our top 4. And then what we're looking for is, well, what's the next tallest one out of our remaining options? And you can see that the next tallest one is going to be NL. So that is our answer for question 2. So that's the basics of a bar chart. Again, you just want to give yourself time to really understand the data that's being presented before you dive in to the questions, and then just be careful as you go through the questions themselves. Next up, we will go through a pie chart, and it is the same exact punchline. So we're going to go ahead and give you maybe a bit longer here, maybe 20-30 seconds, to just look at the chart itself, determine what information is being given to you, and then we will go through the chart and then add some questions in as well. All right, so let's talk about these pie charts. We're given 2 different pie charts. They're called pie charts because they look like slices of pie. And the nice thing about pie charts is that they're going to add up to 100% of your population in some way. So you can just look at this and get a sense for what piece of the pie falls into each category. So for this particular one, we're told that the 2 charts show how female and male survey respondents answered a question about how often they eat a certain type of food. So just taking that and looking above, one thing that pops out to me is that we don't have any hard numbers at all. Our pie chart just adds up to 1.0. So what we're given here is more about percent or about proportion than it is about actual numbers, right? We don't know how many people they surveyed. They could have surveyed, 1,000 men and women. They could have surveyed 1 million, right? That kind of thing. We have no idea how many people actually fall into each of these wedges. We just know what chunk of the pie they take up. The other thing that pops out to me is that they've marked this 0.2, 0.4, 0.6, 0.8 around the pie, which just gives you a really nice visual cue for kind of, what percent falls in each area. It would just be a little bit trickier to see that without those additional guiding points. So for instance, on the female pie chart, we see that 0.8 cuts right through the middle of the not sure category. So that's not an actual line that cuts the data in half. It just tells you that, hey, the 80% mark falls, kind of in the middle of that chunk. The next little detail that we get in the description is that infrequently meant more often than rarely, but less often than occasionally. That's kind of a mouthful, to be honest. But here I'm just looking at the key, and I'm seeing that it's written in a way that makes sense. So it is going from I eat it the least often to I eat it the most frequently. And then it's just that those particular words, are a little confusing, right? Just without that additional context, what does rarely mean versus infrequently? Well, this just tells us that, hey, it's in order. So that's good to know. That's nice. So that's really what there is to get out of these pie charts. We'll go ahead and throw a question up on the board. It's just one question for this one. And take your time, answer it, and then we will chat it through. All right, let's go through this. So the question asks slightly less than what percent of certain respondents indicated that they ate the food at most, rarely, infrequently, or occasionally. So what we have here are two blanks in one sentence. Those two blanks depend on one another, so I can't independently choose an answer for the first blank and then independently for the second blank. It really depends, kind of what goes in that first one will change what goes in the second one. To me, what stands out here language-wise are these words at most. So what does it mean to say at most rarely? Well, that would be just starting from 0 and then going to wherever rarely ends, right? Versus what does at most infrequently mean? Well, that includes that earlier portion, rarely, right? Because both my rarely people and my infrequently people fall into that bucket of at most infrequently. So I'm always going to be starting at the top of the pie chart and then kind of seeing like, where does this end up? And then is there an option that works for that? So here, I do think it's easiest to start with the second blank and then look at my options for the first blank to see if there's a pair that actually makes sense. So let's do that, and we'll just start with rarely. So slightly less than some percent of respondents indicated that they ate the food at most rarely. So for our women, if you look at that chart, we get, 8% maybe said that they ate rarely. And then for our men, we see that we've got about 30% saying that they ate at most rarely. So 10% of the male eating at most rarely. Nope, way more than that, 8 rarely, so that doesn't work. B, 20% of the female. Nope, way less than that, 8 rarely, so B doesn't work. For C, we've got 30% of the female. Again, way less, so same reasoning as the previous one, can get rid of it. And for D, 40% of the male. So it says slightly less than, and again, we've got about 30% of our men eating the food at most rarely. That's a pretty significant chunk below. So maybe if there's no better options, I would keep it, but for right now, I'm gonna say that's pretty far off. So I would go ahead and get rid of rarely, because there's really no option that fits well for that being our second blank. Let's do the same thing for infrequently. So eating at most infrequently, if you look at the female chart, we've got about 19%. If we look at the male chart, we've got, what, maybe 45% that are eating at most infrequently. So slightly less than 10% of the male for infrequently, no, way more than that. Slightly less than 20% of the female, there we go, right? We said that about 19-ish% of our female respondents ate that amount, and that corresponds really nicely with slightly less than 20%. So the pair here that works is slightly less than 20% of the female respondents ate at most infrequently. So that's a pie chart. Here we've got some small quirks that you might not see in other pie charts, but that's the name of the game on the GMAT. There's always some, slight twist. But at the end of the day, what a pie chart is just showing you what wedge corresponds to what thing in your key. So we will go ahead and do one more kind of common chart type. It's going to be a flow chart. This one is a little bit more convoluted, so we'll give you a bit more time, maybe 30 seconds, to go ahead and kind of see what's going on with the flowchart. Then we'll talk about it, and finally we will finish up with some questions. All right, let's talk about this flowchart. So first thing I'm doing is just taking a glance at the chart itself. It looks like we've got a begin, so something is starting, and then we've got a whole bunch of different options that happen. And then at the end of the day, you can end up in one of 3 buckets. You either pay on entry, pay on exit, or ride free. So that's intriguing. Let's go look at the description to see what exactly we are paying for or riding free on. The description says, a certain city's bus system includes several stops within a university campus. The city has devised a new plan to decrease the amount of time bus drivers devote to receiving payments at the busy university stops. Under the new plan outlined in the diagram, passengers would pay on entry, pay on exit, or ride free depending on the time of day, on their boarding and departure locations, and on whether they present a valid university student identification card. So what I'm getting out of this is just kind of a nice rundown of what all is located in that chart. And particularly, I'm interested in these criteria that decide which bucket you end in at the end of the day. So it looks like the criteria are the time of day that you enter the bus, their boarding and departure locations, and then whether you present a student ID card, right? So based on those 3 factors, you will end up in one of these 3 outcomes. I think that's a good place to leave it for now, and then we'll go ahead and look at the question and see what we can get out of it. Again, I'll throw it up on the screen for a couple minutes, take your time, and then we'll go through it. All right, let's go ahead and talk through this question. We have, according to the diagram, under the new plan, if a bus passenger does something, then that passenger must not have done something else. So these blanks, again, are dependent on one another. We can't just look at them in isolation and decide on the first one and then on the second one. We have to look at both and see if there's a pair that works for both. The other thing that really stands out to me here is this word must and this word not. So must not means it just can't happen, right? So if this first thing did happen, then this second thing just can't have happened. That's what we're looking for to correctly answer this question. So here I think it's easiest to start with the first blank because we have these buckets that you end up in at the end of the day. So what we can do is we'll start with A, rides free, and just see, well, how could you end up riding free? And then is it true that you must not do one of these things to end up, in fact, riding free? So let's do that. To end up in that bucket of riding free, to me I see two pathways. The first pathway is pretty simple. It goes along the top and the side. So if you board during the day, so between 6 a.m. and 6 p.m., and then you present your student ID, guess what? You get to ride for free. That's very nice. The other thing that ends up in the rides free bucket is if you board between 6 a.m. and 6 p.m., but you don't present a student ID, there is a way to make yourself kind of come back to that rides free bucket. That's where I'm going to leave it for now. I don't want to get too in the details until it is relevant to the option that I'm looking at. So again, we're looking for, if they end up in the rides free bucket, what must not have happened. And let's go through our options. A, you must not have boarded between 6 a.m. and 6 p.m. Well, we just said that to end up in the rides free bucket, you have to board in that time, right? So this is the opposite of what we're looking for, so A is out. B, you must not have presented a valid university student ID. Actually, on that first path, that pretty simple path, it is if you do present the ID, then you end up in the rides free bucket. So B is not A, must not. We can get rid of B. And then finally C, the passenger must not have boarded at a university bus stop. So this is where we kind of look in those weeds and those details. The boarded at a university bus stop is in the middle column, that first flow bucket thing. So let's answer yes to that question. In C, hey, can we actually ride free when we board at a university bus stop? So if I answer yes, then I go down to the exit at a university bus stop. If I answer yes to that, I end up riding free. So again, we're looking for something that must not be true. And because there is a way for that to be true, then C also does not work. In other words, we have 0 things that work with the rides free option. So we know for a fact that the rides free is incorrect. Let's look at our other kind of like end of the day outcome buckets. So pays on entry, let's again look at the chart. So to end up paying on entry, it looks like, again, we've got two paths. There is one path that says that you don't board between 6 a.m. and 6 p.m., so you board sometime at night. You got to pay on entry. And then there's another path that goes all the way through this convoluted thing, with the ID and with kind of where you're entering and exiting, and it's possible to make your way back to paying on entry. So with that in mind, let's see if there are any things that work for the second blank with pays on entry. So passenger must not have boarded between 6 a.m. and 6 p.m. Well, we just said there's two pathways, right? One is if you answer no to that question, but the other is you answered yes, right? So you did enter between 6 a.m. and 6 p.m. and you make your way back to the pays on entry bucket. So because there's a pathway back, then we know that A isn't R1, right? You can board between those times and pay on entry. B, must not have presented a valid university student ID. This one's a little tricky, I think, because that first path that we talked about, where you board at night, it just doesn't talk at all about your university student ID. So for those people, we just don't know. Are they presenting it? Are they not? It's just irrelevant. They all have to pay on entry. So you could imagine a student getting there at 7 p.m., they show their student ID, guess what? They still have to pay on entry. So this one is out because it could be true or it could not be true. We just don't know for those night riders because it just doesn't go through that bucket at all. So that doesn't work. I'm doing this in a confusing way. Right now we're talking about pays on entry. We know that A is not going to work. We know that B is not going to work. I'm going to, for clarity's sake, get rid of that. Let's look at C. So to end up paying on entry, the passenger must not have boarded at a university stop. Well, let's again go to our pathways. This falls into that same category as B, right? So for the people who are boarding at night, where are they boarding? I don't know, right? Could be at a university stop, could be at a non-university stop. We simply don't know where they are boarding, and yet they're having to pay on entry every time. So it's not true that they must not have boarded at a university stop. We don't know where they're boarding if they're boarding at night. So C is out, which means that there are no options that work with the pays on entry blank for 1. So hopefully there is something that makes sense for pays on exit. Let's take a look. Again, going back to the flowchart. Looking at this flowchart, there's actually only one path to get to pay on exit, which is nice. Makes our life a little simple. You have to go through a very specific set of events, yeses and nos, to get to that pay on exit. So to pay on exit, then the passenger must not have boarded between 6 a.m. and 6 p.m. Well, if we look at this one path, the only way to get to pay on exit is if you do board between 6 a.m. and 6 p.m. So it's the must not really messes up here. It's the opposite of what we want. So that cannot be true. To pay on exit, the passenger must not have presented a valid university student ID. Well, let's go ahead and look at our one pathway, right, the only thing that possibly works, and see what happens with the ID situation. You have to answer no, right? That's the only pathway, and it's a no on that university ID question. So in order to end up paying on exit, you just cannot present a student ID. So that is why B is going to be our correct answer. And if you just want to, just make sure, is it that the passenger must not have boarded at a university bus stop? Well, again, the only pathway says that you have to answer yes to that question, right? So you actually do have to board at a university bus stop in order to end up into the pay on exit bucket. So C is out, and what we get here is that you must answer C for your first blank and B for your second blank. And that is the correct answer to this question. So when a graph or a chart pops up on the screen on your data insights section, all you want to do is give yourself time to really understand the big picture of that data before you go ahead and dive into the exact questions. So that's going to involve looking at the description of the graph, looking at the axes on the graph, any keys, that kind of information, and then maybe tell yourself a bit of a story, pick a data point to see if you can understand what's happening at that data point, just to make sure that you're really grounded in what that information is telling you before you dive into the specific details of the question that is asked. This is Dana with GMAT Ninja, and I hope you have enjoyed this video, and I will see you next time.